Hello and welcome to the October 2020 Stanion and Northants Astronomy Club's Skyguide for the month ahead. So as usual, I'm going to run through what you can see in the night sky this month. Got a little bit of news at the end and some images from some club members. So, and if you ever want me to share any of your images on the end of this Skyguide, just drop me a message on Facebook or through the club's email address, which you can find on the Facebook site, and just send them to me, and I'll pop them in here with all your details and full credit given, of course, and we can show people your work. So I'm gonna kick off here with Venus, because Mercury is out the way this month, really hard to see or impossible to see throughout October. So straight into Venus, which is a very bright morning object. You might have seen it already if you're up in the early hours of the morning, shining away at mag minus 0.4. And this screenshot I've put on here is from the morning of the 3rd of October. So in the early hours of then, you'll be able to see Venus passing very close to the brightest star of the constellation Leo, which is Regulus. And it will be 12 arc seconds from Regulus, and the little round screenshot I put here is the view that I would get through my telescope with a 25mm eyepiece on, so you'll be able to fit them both into the same field of view of a telescope with a long enough focal length on your eyepiece, of course. The contrast between the star and the planet might be somewhat different, because Venus is minus 4 mag at the minute, although Regulus is quite bright itself, one of the brightest stars in the sky. So it'd be interesting to have a look at those through a telescope. And on the 14th of October, Venus is joined by a 10% waning crescent moon, so look out for that as well. And here's that screenshot showing the position of the moon underneath the constellation of Leo, alongside Venus, and how it would look here. So look, it's the waning crescent is almost on its back, next to the bright planet Venus. And here's a moon and Venus image that I caught, I think it's almost 5 years ago now. I got this one. They're much closer together, and I could get them in the same field of view in my telescope. But it just shows you how they look next to each other. Moving on now to Mars. It's currently at mag minus 2.6, and it rises after it gets dark. You can see it rising in the east, and it's visible all night long. And it will be at opposition on the 13th, which means so it's the best position. The Sun is in exactly the opposite part of the sky to where Mars is situated, and so it will present a full disk to us. And as you can see here on the right of the image, it's a picture that I took in the middle of September of Mars. I managed to get some of the details of the darker regions on the planet's surface, and also I've caught, I think, this southern polar cap of Mars. The polar caps are showing up quite nicely in a lot of images recently. So really well worth having a look at Mars, through a big enough telescope, or if you can image it, you can bring your gain right down the camera and make out some of the darker regions and the polar cap too. So my wife just brought me a coffee. I'm going to show you my coffee mug here. All constellations on there. Right, moving on now to Jupiter. It's a mag minus 2.2. It's visible after sunset in the south. And on the 22nd of October, it's joined by a 41% waxing moon close by. And as you can see, you've got Jupiter there highlighted in the middle of this Stellarium image. Below it is the moon on the 22nd, and then over to the left you've got Saturn as well. So it forms kind of like a right angled triangle between those three bright objects in the sky on the 22nd. And I'm highlighting this Io transit as well on the 6th of October. I think the transit starts at around 5 to 7 in the evening, Might still be a bit bright then, but that's when Io enters Jupiter's disk, and then right up until it's almost 10:15 is when Io exits Jupiter's disk. So you can probably see that, through a telescopic view. And then also just before it exits, you can also see here the shadow appearing as well upon the planet's surface. So well worth having a look out for that. I'll show you in a minute how you can find out that sort of stuff for yourself on Stellarium, like how I find out. Here's an image here over on the right hand side of the screen. This is one I took a few years ago of an Io transit. See Jupiter's disk here. You can see the shadow of Io here. So I'm not sure if Io was one of these moons here, depending on the position of Jupiter relative to the Sun, the way it casts its shadows. I'm going to switch now to Stellarium if I can. Here we go. So I'm just going to do this, and the way that I find the transits of the moons of Jupiter is by finding Jupiter in the night sky first of all. You can zoom right in. You can zoom right into the planet. There we go. So now we can see the planet. Right, and then what I do now, see how I've got the time and date set down here. I've paused it at the minute, so it's not moving. But this is set to the 2nd of October, and then all I do then, oops, you've got to remember to center the object in your field of view, else it disappears when you change the time or date. So then once you start doing that, there we go, straight away, the 3rd of October, we've got a shadow transit happening there. It looks like it's Io, and then you can reverse time. I should have picked this one. The 3rd of October, there you go. I mean, this is at 7 o'clock, you can see the screen brightening, which means, the sun's not quite set yet, but then as the sun sets, the image gets darker, and you can see the moon moving off the planet's disk, and then the shadow is still there. Oh, and then here we go, we've got the great red spot coming into view as well, so it appears that the 3rd of October might even be an even more enjoyable transit to watch, because you'll have the bonus of the great red spot coming into view at about 8 o'clock as well. The only thing to look out for here though when you're watching this is if I zoom out, you can see the position of Jupiter. This is at 8 o'clock on the 3rd of October. So it's just gone south, it's just past south, but if I fast forward as it gets towards the end, see Jupiter is getting lower and it's going more towards the west, so you do need quite a good south-southwest horizon to view the whole transit. So if I go back to turn Stellarium off for now, go back to my presentation view, and I can then carry on. And right, moving on to Saturn, which you can see from the previous image is over to the left of Jupiter. It's a bit fainter than Jupiter. It's shining at mag plus 0.8, and it's visible in the south, same as Jupiter, after sunset. And its visibility, even though it's a bit dimmer than Jupiter, the visibility is getting aided by the month end. The days are getting shorter, so that means the nights are getting longer, so we'll get more dark hours, so you'll be able to observe Saturn a little bit more easier as the month comes to an end. And here's an image here I took of Jupiter a few years ago. It's in black and white because I used an infrared filter on my CMOS camera, which sort of cuts through the atmosphere a little bit better and gives you a slightly better image. So moving on now to Uranus, and then of course Neptune as well, two outer planets, a couple of ice giants in the solar system. I always like to use Stellarium, or you can use a mobile app, which is better when you're outside of the telescope, to make yourself a little star chart like this. So you can see the constellations here, you can see its position relative to the constellations. Then if you zoom in, make yourself a little star chart. You can see what stars in the constellation, the brighter stars, to use as pointers down towards the general area where you're going to find the planet. And then I've used this telescope view here to see what you would find through your telescope and eyepiece combination. You can set that all up in Stellarium as well, and it's a really handy tool to use for really finding out if you're looking at the right object. I mean, mag plus 5.7, so Uranus should be, it's just on the cusp of naked eye visibility, but realistically from a town, with light pollution and that, you're going to need an instrument, binoculars or a telescope, to see it. So there we go. And also this planet also reaches opposition on the 31st of October, so that is best position for the year as well for observing that planet. Moving on to Neptune, same applies as with Uranus, what I just described. Using Stellarium or another planetarium app to find yourself a nice sort of star chart, using some brighter stars in the constellation as pointers. And again, here's the view through the telescope. Neptune, probably the colour of Neptune is more vivid than Uranus, so you probably pick that out a little bit easier against the stars that surround it. Although it is a little bit dimmer at mag plus 7.8, so it definitely will need an instrument to see Neptune. Okay, moving on. Not many bright comets around this time in the year at the moment, so I picked this one up from inthesky.org. So you will need an instrument to see this comet, preferably a large aperture due to its brightness. You can see down here. Here's a little clip I took from inthesky.org from the objects list of comets. It's at 11.2 at the minute. It is fading, but a large enough aperture and enough images taken, you should be able to see some sort of movement in the sky over the course of a few hours, I would have thought. On any given night, you can see it starts the month here in Cepheus, and it's making its way down through Cygnus as well. So it's nice and high in our skies at the minute. So even though it's dim, it is well positioned. And if you've got a big enough instrument, or you can do a good enough exposure with whatever camera you're using, then you could be able to pick out this comet throughout the month. So it's always fun to watch a comet and be able to track it yourself from your own back garden. A couple of deep sky objects I'm going to highlight this month: the Dumbbell Nebula and the Ring Nebula, which are in the summer triangle. So even though we're going into autumn, the constellations of the summer triangle are still nice and high in our sky. The Dumbbell Nebula is in the lower part. My phone's going off. I shall ring those back in a minute. Sorry. Dumbbell Nebula. You see the three bright stars of the summer triangle here, and here's the constellation of Sagitta, and got Vulpecca here, and it's in between those two dimmer constellations within the summer triangle. And I always find this a little bit more difficult to find than the Ring Nebula, even though the magnitude is a little bit brighter than the Ring Nebula. It's spread over a larger surface, a larger area of sky than the Ring Nebula is. So its surface brightness is a bit lower and makes it a little bit harder to see. Although I think you can just make it out in a finder scope if you're in the right area. I always start at Sagitta, the bright stars here, make my way north through my finder scope, and you can find a little asterism of kind of like a bowl shape of stars, and it's near a star which is near the centre. So I'm sure if you make a star chart, we'll zoom in like you do when you're looking for Uranus or Neptune, you can find that quite easily. And here's an image down here below that I took of Dumbbell Nebula. You can see how it got its name. It actually looks a bit more like an apple core to me. It's actually a planetary nebula. It was caused by an explosion. A star went supernova, and this is the remnants left over. And they're called planetary nebula because I think years ago astronomers used to think that they looked like planets. They thought they may have been planets, but they've turned out to be nebulas. And the Ring Nebula over here, the brighter of the, relatively brighter one of the two, especially in my images here, is in the constellation of Lyra. And I find this one much easier to locate because Lyra, constellation, the brightest star is Vega, and just below Vega, you can make these out with the naked eye. You'll see two pairs of stars just below Vega, and the second pair of stars, the Ring Nebula, you can see where I'm highlighting here with my mouse, is situated, it's about 2/3 of the distance between the two stars there. So just hunt around with your finder scope between those two stars, and you'll see that quite clearly. Although it's quite a smaller object, much smaller than the Dumbbell Nebula, in our night sky. It is nicely visible as a smoky ring through the eyepiece. of your telescope, and then if you take images, of course, you can then bring out some of the nice colours that are visible there, and sometimes you can just make out the neutron star in the middle there, of which the nebula is the remnant of. So moving on, here's an image of the Ring Nebula by one of our members, Dave Booth. He took this quite recently through his telescope, and you can see the field of view of his telescope, and then how small the Ring Nebula does look, but you can still make out the shape of it there. It's a really nice image, shows it against the background of stars. And here's the Dumbbell Nebula as well by John Allen, another member of our club. Quite lots of detail in the nebula cloud there. You've got the brighter region in the middle, which is different gas, and then you've got the hydrogen gas on the outside of the nebula as well. A really nice image. And so that's the end of that part. Moving on to Iss Passes. You can see the space station is currently visible in the evening until the 6th of October, and then it passes. Then it changes to morning passes from the 22nd of October. And I usually use heavensabove.com or the ISS detector app on a smartphone to see when you'll be able to see the space station coming over and give those astronauts a little wave. Here's an image I took last year of the space station coming over, stitched together in, I think it was star stacks, and just sticks to lots of I usually take between 8 and 10 second images of the station coming over, and of course you see the star trading starting to happen there in this image, and it just shows you the path of the space station coming over. So if you're in the right place at the right time, you can get in a good image of the space station too. So moving on to some member images now. So this is Mars, taken by Graham Algeo around about middle of September. I think it might have been the same night as I imaged Mars as well. He's got lots of images here. He was playing around with different cameras and different telescope combinations to see what worked best for him. So it's always cool to experiment with different equipment if you've got the availability of it. And he too has made out some of the darker regions on the planet's surface, and the polar region too. So really nice image there from Graham. Moving on now, we've got John Allen. He shared this on Facebook. This was last month. I highlighted how Jupiter, Saturn and the Moon will be in a triangle sort of formation on one particular evening, and this evening John went out with his, looks like a DSLR camera, and maybe even a smartphone camera, and took this image. And you can see there in the centre there, you've got the Moon just brightest, you've got Jupiter over here on the right, and then Saturn just above the Moon there. And here's a close-up of the same image that he took. And then this month, of course, you'll be able to see the same sort of configuration of the Moon, Saturn and Jupiter, but the Moon will be over here to form the right angle triangle, the three objects. It's a really nice image again. And it's so easy to do. If you've just got a normal camera or a smartphone these days, you can take cool wide field images like this. And next image I've got on here is by Paul and Ruth Smith. They took this image of the Moon on one of their retreats to Spain, I believe, a little while ago, through a telescope, a 6-inch Newtonian. They had a 2x Barlow lens, and used a DSLR camera. There's exposure details there as well. I think they used two images. They stitched them together to make one image of the Moon, and then they used Dave Eagle, our friend Dave Eagle. They used his guide, which was in the Sky at Night magazine, how to create a minimal moon astrophoto. So it really brings out some of the colours on the lunar surface. You wouldn't see them with the naked eye, but a little bit of processing with Affinity Photo or Photoshop, whatever software you use, you can really start to bring out the colours of the different minimal sort of areas located on the Moon. You can see this region here is a lot more blue and dark than these brighter regions in the Highlands, and this is a little bit more redder than this Mare up here. So it's a really cool thing to do. And this was taken in, was it Torrevieja in Spain? So which in the next slide I'm also going to plug Paul Smith's Spanish Torrevieja Astronomy group here as well, because they've got a free talk on October the 14th at 6 PM British Summer Time. It's entitled "You Can Almost Touch the Stars." It's by Tom Field, who lives in Seattle in the USA, and he's doing this via Zoom. So if you want to join in this Zoom meeting, you can contact Paul Smith, and there's his email address there. You can contact him there, or he's also on Facebook, or you can contact me and I'll put you in touch with Paul as well, to get details of how to join in the Zoom meeting on October the 14th, 6 PM. So his talk will be about how to see the light from a star as it's split with a diffraction grating, and it gives you all the colours of the spectral lines of that particular star, and then you can analyse it to produce a spectral graph, so you can actually see the makeup of the star just by looking at the light. And this shows you how, this talk will take you through how that is achieved, and how as an amateur you can do the same sort of thing from your own backyard. I know people do this sort of thing, not something I've touched on myself, but it is a really interesting sort of real piece of science that you can do from your own back garden. There you go. So do get in touch with me or Paul directly, and if you're interested in listening in on this Zoom meeting, or watching the presentation from Tom Field. So moving on now, here's an image that I did as well, middle of September. This is Pickering's Triangle, which is part of the Veil Nebula in the constellation of Cygnus. So it's a nice and high object for us at the minute still. Looks a bit like a cosmic pizza slice to me. So this image is in monochrome, it's in single colour here as well, because I used a hydrogen alpha filter on my modified DSLR camera, so it's had its UV IR filter taken out. I put the hydrogen alpha filter on, so all I'm collecting is light from light that is emitted by the cloud of hydrogen, which this is. So I had to do a really long exposure on it, and I think it was 5 minutes, and at a high sensitivity on the camera as well, but it was well worth it. This was a combination of I think 12 or 13 images taken on one night, and I was managed to process it in Affinity Photo to give me this final image. So I can see the details of this nebula network, all in this one monochrome image. So I was really pleased. It's my first outing with the hydrogen alpha filter, and if you want to see it in a bit better resolution, you can go to my Flickr page. Just go onto Flickr and search my name, Damien Weatherly, and you can see that and more of the images that I've taken as well. I put them all on Flickr, so you can see them in a better resolution, and you can see the details as well, how I've captured it and what I've processed it with. So I'm going to finish up now with a couple of bits of news. Also in September there was a big announcement from some observatories in America. They think they've found potential signs of life in the clouds of Venus. So what they've seen is they've detected phosphine gas in the clouds of Venus, and then they've tried to rule out, or I think they've possibly ruled out every other possibility of how phosphine could be produced on Venus, because I think here organisms, microorganisms which don't rely on oxygen, do actually produce phosphine gas. So I suppose their next steps now will be to come up with a mission to Venus to get in and be able to study the clouds, or to potentially take direct readings from the clouds themselves and see if they can actually directly detect any signs of microbial life in the clouds. It is quite habitable apparently in the clouds, conversely to the harsh conditions on the surface. They might be just right for spores or microbial life to float around in the clouds quite high. I think it's around about 30 miles high in the clouds of Venus where this was detected, so nowhere near the surface at all, but just somewhere where I wouldn't have, probably the last place I would have looked in the solar system, somewhere like Venus. But very interesting, very exciting news. It was so exciting in fact that I think the Skyguide cancelled their originally planned program, and they replaced it with a special on this discovery. So it'll be interesting to see what sort of mission the space agencies come up with to go ahead and explore the planets in this the planet's clouds in much more detail. So watch that space, everybody. I just read this article this morning myself. There was an Earth-grazing meteoroid. It was recorded bouncing off of our atmosphere. Now this image, or this animation, was taken on the Global Meteor Network, which is, I think, it's a decentralised network of cameras set up all around the world by, a lot of them are set up by amateurs, to keep an eye on the night sky, to look out for meteors, especially bright fireballs. But this was an Earth-grazing meteoroid, so it didn't actually touch the Earth's surface. It came in at just the right angle, at just the right speed, and to enter our atmosphere, but then keep on going and escape the Earth's gravity because it had enough of velocity, to carry on going back out into space again. So very rare to see them recorded like this. They probably do happen quite more often than we think, but obviously if no one sees them or records them, we're not going to know about it. So it's really cool to see an image like this. Normally they last a few seconds. A meteor, it burns up in the atmosphere. This one's moving relatively slowly across our sky, and escape the Earth's grasp. So that's a really cool image to see. And that takes us to the end of this month's Skyguide. So I hope you all enjoyed that, and you find some of these bits of information I'm sharing here interesting still. I'll speak to you again next month. So thanks for watching. Do like and share and subscribe if you want to keep an eye on what I'm sharing each month. And thanks very much. Bye.